So thanks for coming back. Finally, this is the last review lecture. This time I will talk about challenging quizzes that you saw through 10 modules. Again, I will try to explain based on my understanding, but as I'm a learner in this course like you, your feedback, corrections, and any comments will be really important. So, control variables. To answer this question, first you have to distinguish which one is independent and which one is a dependent variables. So, advertising campaign is independent variable, and the number of riders is dependent variable. In fact, the control variable is not the campaign itself, but the fact of controlling one group with viewing the advertising and the other not. So the variable implicates the before and after posting the campaign at the bus station. And if we want to know whether a significant difference of riding numbers, we can adapt independent sample t-test to compare the means of the number of riders from the two groups who didn't see the poster and who saw the poster. Bar chart and histogram. So histogram is used for the continuous variable frequency. So you can see here, you cannot see the gap between, but this one is a bar chart. You can see the gaps between the bars that is used for the categorical variables. And you can put more categorical variables in the x-axis. So the answer is a bar chart. Standard deviation. So when a mean is 100 and the standard deviation is 10, the normal distribution graph can be shown like this. So it's the standard deviation 1, 2, 3. And the 95% of scores fall into this area, so 80 and the 120. So that should be the here 95%. That was the mistake. So skewness, if you remember, the professor said we can distinguish when that goes to the positive side, that is a positive skew. So in that case, the mean is more placed in the left side. So in this question, the younger participant, the mean is situated in the left side. And when that goes to the direction of the negative side, that is a negative skew. And the mean is placed more the right side. This is the more scores of the older participants. So you can find the by this way where the cluster happens. So the variability. To answer this question, first you have to understand what is the relationship between the standard deviation and the variability. So when standard the deviation is more close to the mean, this means is less variability in scores. And when the standard deviation is more far from the mean, this means that there are more variability in the scores. So to answer this question, the which variable shows the least variability, we have to know the how standard deviation is situated from the mean. So this is the what I calculate. So standard deviation, you can divide by the mean and multiply by 100. You can obtain the level of closeness to the mean. So you can calculate all variables and you can find the variable 2 shows the standard deviation is most close to the mean. And in this question, which variable shows the standard deviation most far away from the mean? So you can calculate it as the same thing what I did. And you can find the variable 4 shows the standard deviation is most far away from the mean. So this means that a variable 2 shows the least variability because the standard deviation is close to mean. And variable 4 shows the most variability because the standard deviation is most far from the mean. So interquartile range. So what does this blue box represent in this picture? So you can review your interquartile range the explanation. So you can divide the 4 equal parts of the scores, and then we can obtain the first interquartile and the third interquartile and also a median. So this value exactly in the box and whisker plot and situated in this line fourth quartile and the third quartile, and this is a median value. And also, we can obtain the minimum and the maximum value by this formula. When you see this box and plot, the if the one score falls in outside of this minimum and the maximum line, and then that can be considered as the extreme score outlier. So the answer is the interquartile range. This box represents the interquartile range. And the variance and the sum of squares. So the sum of square is a square total deviance, and the variance is the average of the sum of squares. So both values have limitations because the sum of squares change depending on the sample size, and the variance is the squared numbers. So we need a standardized value for showing the degree of the deviance from the data. So for this reason, a standard deviation is used to show the degree of the deviance. Validity. When a test result is still valid in a real situation, that satisfies the criterion validity. So people who have a high score in the job skill test still show their good performance in the real situations. And ratio and fraction. So as you know, all these values are equivalent. So in fact, there is a mistake here. That should be in the 1 to 5. So in a correlation regression, when we talk about just the relationship between the two variables, that correlation test is adopted. And if an independent variable predicts the outcome of the dependent variable, then regression test is adopted. P-value and the null hypothesis. So many students have a confusion with this part because the p-value that is bigger than 0.05, and then we accept our null hypothesis and we reject our hypothesis. So because test is not significant. And when the p-value is equal to 0.05 and or 0 is less than 0.05, and then we accept our hypothesis and we reject our null hypothesis. So here the answer is the number 1, because the number 1 and 3 p-value is less than 0.05. So we accept our hypothesis, but we reject our null hypothesis. And the number 2 and 4, the p-value is greater than 0.05. So we reject our hypothesis and we accept our null hypothesis. And be careful about the p-value because that is between the 0 and 1. So no 0 in the front, and that should be reported with the 3 decimals. So chi-square and calculation. To calculate the expected value of the engineering, you use the formula. The engineering, the total of the row and the total number of the column. So you can see here you can multiply by the total number 100, and then you can obtain the number 0.5. Chi-square residuals. So what you should really understand, in fact, is not the sign of the negative and plus determines the difference from the expected values, but the bigger number, or either plus or minus, that determines how observed values are distant from the expected values. So minus sign means the observation is less than expected, and the plus sign means there is more than expected. So in this table, the minus 1.3, that shows the most distance from the expected value in the direction of the less. So male students who want to go high school is observed less than expected. But in fact, in this table, all numbers show that there is no significant difference between the expected and observed values, because that significance should be more greater than plus minus 1.96. So anyway, the answer is the male high school. That is the most difference. It tests p-value and the significance. So when p-value shows it like this is insignificant, and we can interpret the result with the non-significance. So as you see that this p-value is greater than 0.05, even though there is a small difference between, the difference is not significant. So we can conclude that there is no difference between the engaging the social media platforms, even before and after. Correlation variability. So the value R is 0.80, means that two variables are interrelated, sharing the same variability of the 80%. So they are influenced by the same factors as much as the 80%. Consequently, only 20% are not correlated and are separately influenced by the other factors. So t-test critical values and two-tails. So in this test, to find if there is a difference of means, if it's significant, we have to compare the observed t-value with the critical values. So we can see that the degree of freedom is 6. So with the two-tailed 0.05, we can find the critical value is 2.447. So the reason why we take two tails is because the mean difference can be either positive or negative. Positive t-values means the observation is larger than expectation, and the negative t-value means the observation is smaller than expected values. T-test statistical assumption. So in t-test, the homogeneity of the distribution is related to the standard deviation, because it shows how the distribution is deviated from the mean score. So if the variability is not the same between the two groups like this causes the homogeneity problem when we run the independent sample test. Correlation and R value. So the R value for the correlation and the beta value for the regression, both the values are between minus and plus 1. So this shows the strength of the relationship between the two variables. So minus value indicates the negative direction, and the plus value shows the positive direction. So the bigger numbers, either positive or negative, means the strong relationship. To obtain the effect size, the square R value in correlation and the beta value in the regression. And this is shown as the R square value here. So that shows the effect size. So this covers the review of challenging quizzes, and I hope you could get more understanding about what was not clear to you. Me also, I have really learned a lot while preparing these review lectures. So I sincerely thank Professor Rocky, who gave me this opportunity. I wish you all the best. Bonne continuation à tout le monde. Thank you.